Okay, today we're going to talk about the rock cycle. It's an important concept in geology or earth science that they call it at your school. Essentially, it's a question of different kinds of rocks and from where they come. Um, Magma is a liquid rock. It's very hot stuff and it's under the surface of the earth and often comes out onto the surface from volcanic eruptions and it creates igneous rock, rocks like uh, basalt and granite. These are usually very tough, very hard rocks. Um, Granite is good for making buildings and countertops and stuff like that. It's very heavy stuff and it's expensive to quarry out and cut up. But when you build things out of it, they tend to last a long time. But igneous rocks like granite are just a magma, these liquid minerals from under the earth that have cooled. They've either exploded out of a volcano or they've come up close enough to the surface that they can cool off. They're still underground, but they can cool off. Um, Igneous rock sometimes stays under the ground or gets buried again and exposed to a lot of heat and pressure, and it becomes metamorphic rock, like marble. Um, Metamorphic rock, sometimes when it's exposed on the surface, gets weathered. It ends up in rivers or exposed to wind or rain or what have you, and it gets broken up into little pieces, and that becomes sediment, like sand, dirt, dust. Sometimes the sediment gets compacted and forms sedimentary rock, like sandstone or limestone. And sometimes that gets buried again deep enough to become magma. Now, this chart gives you the impression that all rock sort of goes through all of these stages in this order, but that's not necessarily the case. Metamorphic rock could get buried and turned into magma, or sedimentary rock could get buried and turned into magma, or igneous rock could get weathered and turned into sediment, or sedimentary rock can get weathered and turned into sediment. All these things can happen in a different order. Sedimentary rock can be buried and turned into metamorphic rock. In fact, a lot of the best known metamorphic rock is sedimentary rock that's been buried and exposed to high pressure and heat. If I remember correctly, anthracite coal is considered a kind of metamorphic rock. It's ancient vegetable matter that all got buried and compressed and eventually turned into coal and then buried very deeply and exposed to a lot of heat, and it got turned into anthracite. Is a kind of coal that's really hard like a rock. It still burns. Kind of strange stuff. Um, let's see. When limestone gets buried and exposed to a lot of heat, um, it can turn into marble, which is very pretty stuff. It's good for making statues and buildings and things like that. When shale gets buried and compressed and exposed to a lot of heat, it can turn into slate. Slate is used traditionally for making shingles. You can take an axe or something like that. And shale, if you ever see it, is really crumbly stuff. I mean, you can just about break it apart with your hands. And slate is a little bit tougher, but slate breaks off into sheets very easily. So you can take an axe or something like that and cut it into sheets, and you can make ceiling tiles or roofing tiles. Uh, a lot of older buildings have slate tiles on their roofs. And the other traditional thing to do with it is to make chalkboards out of it. You can cut a piece of slate, and traditionally in classrooms, you'd write on that with chalk. I guess chalk is also a sedimentary rock. Anyway, um, talc is a kind of sedimentary rock. It can get buried and turned into soapstone, which is a very soft kind of rock. It's easy to work with, but that makes it useful for making all kinds of like pots and little statues and things like that. People traditionally have used soapstone to make all sorts of things for their household. It's not very, those things aren't terribly durable, but it's easy to work with. It's soft, which presumably is why it's called soapstone. I'm trying to think of another. We talked about coal getting buried, and some of it turns into anthracite coal. Sometimes coal also gets buried and exposed to a lot of heat and pressure, and it turns into diamonds. Diamonds are essentially a kind of metamorphic rock. So interesting stuff there. But yeah, this can all happen in different orders. It's not always like this. Sedimentary rock can definitely get weathered and any of these kind of rocks can get weathered and turn into sediment, and any of this stuff can get buried and turn into magma. If you bury things deep enough below the Earth's surface, there's a lot of heat down there. You have to remember that our planet is essentially a big ball of liquid with a very thin shell on the outside, and we call that the Earth's crust. It's only a few miles deep, and the whole thing is several thousand miles across. So most of that in the middle is a very, very hot liquid. And every place you've ever been, every piece of land on which you stood, is on this little shell that floats on top of a big ball of liquid. There's enough radioactive material. Remember, the Earth is only about 4 billion years old, and in terms of radioactive half-lives, that's not necessarily a terribly long time. So there's enough radioactive material buried in the Earth, and all of those radioactive elements are decaying, and they release lots and lots of heat. Each one not that much, but the Earth acts as a big insulator. So there's no place for the heat to go. The Earth is cooling very, very, very slowly. It's radiating its heat out into space. So if you bury things a few miles below the surface of the Earth, they tend to get very hot. And thanks to tectonic action, remember, this shell of tectonic plates sits on top of a big ball of melted rock, and all of these plates move around, and sometimes one plate will move over another. Whenever they collide, sometimes one plate will be forced under another. And the one that gets forced under, remember, that plate is made of this stuff. It's made of rocks and dirt, mostly. And that stuff gets buried and pushed several miles below the surface of the Earth, and it can turn into magma. So there you go. Stuff gets buried, gets melted. Sometimes, due to geologic action, it gets pushed up toward the surface, and it either erupts or it gets pushed up near the surface and it cools. There's a giant sheet of granite, igneous rock, that got pushed up near the surface in the middle of Texas. They call it the Llano Uplift. And but it cooled. I don't think there were any volcanoes there, but that giant sheet of granite cooled under the surface of the Earth, and eventually, through geologic action, was sort of forced up, and a lot of the dirt and so forth over it was weathered away. And so you get, there's a park called Enchanted Rock, I think it's called, and it's essentially a big mountain of granite you can go climb if you want to. It's pretty cool, but it's just a giant mass of granite that got pushed up from under the Earth. That's the rock cycle. Magma turns into igneous rock. That's the only way to get igneous rock. You have to get this rock hot enough to turn it into a liquid. Metamorphic rock is not heated enough to turn it into a liquid. It's heated into sort of a plastic state. It's a little soft, but it's not heated enough to get runny and gooey. Although a lot of the magma under the Earth, even the stuff that turns into igneous rock, isn't really runny like water is, like we tend to think of a liquid. It's more like silly putty. It's or butter or something like that. It's soft and it's plastic, but it's not runny. It depends on how hot it is. It can certainly get hot enough to be a liquid and be runny like water. When it comes out of volcanoes, it's frequently very liquid. I don't know. Did I cover that?
I think so.
All right. So that's the rock cycle. That's where all the different kinds of rock and sediment come from, and what can happen to them eventually.